The Garmin GPS Series navigators, which consists of the GNX 375, GNC 355, and GPS 175, have some pretty detailed weather data available to you via the FIS-B network. Now, the dedicated FIS-B weather page gets kind of complicated, so let's dive into each layer and what this data communicates and how it can benefit you as a pilot. So for demonstration purposes on this video, I'm going to be using the GPS Trainer app that's provided for free through Garmin. So if you want to follow along with me on this video, I highly recommend you do so. This is a great resource to learn your GPS. I am going to be using the GNX 375 as the example here, but just keep in mind that this page will be the exact same for the GNC 355 and GPS 175 as well. So to access the FIS-B weather page, you just click on it here from the main menu, and you have access to this map. Now, at first glance, this map doesn't look that different from the main map used for navigation, just with the topographical feature turned off. The only difference here is that you have access to so many more different weather overlays on this map to give you that much more information for navigating around storms. So let's see what each layer is all about. So to start, everything for this map happens in the menu, and we'll talk about some of the basic configuration settings first. The first setting is going to be altering the orientation of the map, just like on the navigation side. So you can choose between north up, track up, and heading up. Track up is enabled by default, which is what I prefer, but this is up to your preference. Now, at any time, you can view a legend for any of the layers that you have activated. So this will be here. I don't currently have any layers enabled, but let's see, for example, if we want to add the cloud tops feature turned on, now we can see the legend and kind of the color shading associated with the different altitudes. I don't typically use this just because it gets so busy. I do recommend if you have some layers that you do like to fly with, try your best to memorize what the different shading means as far as darker in intensity versus lighter in intensity. It'll make your pilot workflow just that much more efficient. Now, the last non-weather related screen is going to be the FIS-B status page. So this is where you can access the status of all the different FIS-B data fields. So if they're green, they're up to date. If they are white, then it's just waiting for a fresh transmission. And if they're grayed out, then that means that data feature is unavailable at that given moment. So if you have something that isn't populating, like you expect there to be a signature on NEXRAD, but you're not seeing it, you can always come here and just make sure that you have the most up-to-date NEXRAD information. Now, the other cool thing about this is that you can view all of the raw text reports that kind of feed into this page. So although it's not the most convenient from a searchability standpoint, you can search through any of these. So if you want to view NOTAMs for any of these different TFRs and areas, the only problem is like this number doesn't give me a whole lot of information. Looking at TFRs on a map is going to communicate it so much more efficiently. But it is good to have, especially if you prefer to have the raw text data for METARs. You can scroll through here, find the airport that you want to cover, and view the raw text just like you would online. So the first weather-related overlay that I want to talk about is NEXRAD. And if you're not familiar with it, all it does is display a mosaic of precipitation data similar to how you would view a weather radar on your smartphone. It's really nice because the color of the NEXRAD image displays the intensity of precipitation. Now, the one downside associated with NEXRAD is that it's limited in the amount of data that it can transmit via the FIS-B network. So while through your phone or through Sirius XM, you can get a full resolution image, you are limited on the resolution in the area that you can view this information for. So you have a couple of different options here. ConUS is going to allow you to view a low resolution image for the entire lower 48. So it's kind of nice for if you're flying across country or you want to just get an idea of what that image looks like. Just select continental US, and then we can see just where storms are in the area. But unfortunately, there's not a very high resolution image associated with this area, but there is enough data to know like, hey, I probably don't want to be flying Northwest Washington State today. Now, regional is going to give you a higher resolution radar image for an area that is within 200 nautical miles of your current connected FIS-B tower. So it's not going to be centered around your aircraft unless you're directly over the tower, but it is normally a big enough range to make it usable. Although I don't recommend active navigation around storms using passive radar imagery like this, it does help a little bit if you're trying to split the gap between two storms. Combined does combine the best of both worlds here. So it shows the continental US low resolution radar image, and then the regional circle does populate. Now this is kind of funky in the simulator, so it tracks my current location over here in Missouri, but there's no regional coverage on the simulator. I will throw up an image from the pilot's guide so you can kind of see the difference between the regional and the continental US coverage. You'll note that the regional coverage is a much higher resolution image. It's much more usable. So the next weather-related overlay that I want to talk about is cloud tops, and that displays the highest visible portions of cloud within your regional area. So if we look at it here around Portland, we can see these clouds, and the shading intensity, if you remember, can be viewed in the legend. So a lighter color is going to indicate a higher cloud top. Now, it's important to note that if you want to view the altitude of any of the clouds, you can just click on an area, and you see when this cursor populates, it's going to show a measurement down here. So this indicates that the top of that cloud is 10,500 feet. Now keep in mind, this is just kind of an estimate based off of satellite imagery. So it's not going to be 100% accurate. You're not going to be able to get it to the nearest 100-foot interval and be able to just skim over the top of clouds VFR. But it does kind of give you a picture of what the local area looks like. You could probably use it as a good gauge to know, like, hey, am I safe to get on top of VFR and make sure I have some holes close to my destination to get underneath or not. Now, the lightning overlay, although it doesn't work here in the simulator, unfortunately, it will display strikes of electrical activity throughout storms in a similar manner that a storm scope would, with the exception that they don't fade with age. So it's 100% passive data, just like the NEXRAD overlay. So I wouldn't use it, again, for active navigation around storms, but it does just kind of help paint a picture of intensity of precipitation. Now, where FIS-B is unique from a storm scope is that it will group strikes that are close together as a group, and it will show single strikes on their own. So it really helps you get a picture of, hey, the center of the storm's here, this is where it's really active, and then the outskirts still have a little bit of electrical activity. And this is a good time to talk about, you can overlay a bunch of these different layers, but it gets very busy in a hurry. So I would suggest doing it sparingly. I highly recommend only having layers that are complementary to each other. So Lightning and NEXRAD is a great example. If you get to like SIGMETs, G-AIRMETs, and the METAR flags all thrown on at once, it's just a splash of color all over the screen and it gets too hard to decipher. So I just recommend that you use these layers sparingly. Moving on from Lightning, we can turn on the Icing map, which is a pretty cool feature that allows you to view the icing probability for a selected altitude. So you'll see we have a new feature down here, and this is where we can select the kind of altitude chunk that we want to view the icing probability for. This pink shaded area indicates that there's no coverage, or that's typically like if it's below ground level. But as you climb up, you'll be able to see that this map populates, and now we have some icing data to be able to decipher. Now, once again, if we don't know what the different levels are, we can come here to see that lighter colors indicate lower icing potential, and the darker it gets, the heavier. And these little red dots indicate supercooled large droplets of water, which is a pretty high threat to aircraft. Essentially, it's just suspended water droplets that will instantly form as ice on the wing of an aircraft, and it can accumulate very quickly, and it accumulates very clear, so you may not even know that you're picking up ice. So this is a really good overlay where you can adjust the altitude filter for whatever altitude you want to cruise at and get a picture of kind of what geographical areas have icing threats. Now, the winds and temperatures aloft can be kind of overwhelming, so just bear with me. But when you turn this on, you still have your altitude filter, and you'll see that the wind barbs begin to populate. Now, these barbs are the traditional barbs that are read throughout the NOAA or National Weather Service website. Now, I commonly misunderstand these because I act of these being the tail and being behind the wind, but the barbs are actually facing into the wind. So this barb is going to indicate that you have a wind out of the southwest today. So for every short barb, like this one down here, you can add 5 knots. For every long barb, you can add 10 knots. And then for every triangle, which I don't see any here, let's see if we can go up. Yeah, so for every one of these triangles down here, that's equal to 50 knots. So you'll just add those numbers up from your barb reading, and that will tell you the wind speed. And then keep in mind that this barb just faces into the wind. So right here, you're indicating a wind out of the west-southwest at 50 knots. Let's move on to talk about PIREPs now. And this is going to put a bunch of different colored squares on the map for different pilot reports. So a routine pilot report is indicated by a blue square. And if you want to view any more information about it, just click on it and it will pull the translated PIREP up as well as the raw text data. So whatever you prefer to read, it covers basically the location, time, urgency, aircraft type, and then whatever the remarks are related to the PIREP. It's important to pay attention to the aircraft type, especially if an airliner is reporting light turbulence. It's probably going to be more than light turbulence in a single engine piston, so that's just something to keep in mind. Up here we have a yellow square, which indicates an urgent pilot report. So if we click on that, we can view the same style of information. However, the urgent box is checked yes, and you'll see that we've got a Hawker 25 reporting low-level wind shear of plus or minus 10 knots. So oftentimes this will indicate wind shear or severe turbulence or severe light tornadic activity in an area. So it's very important to keep an eye on these urgent pilot reports. Now we can enable the turbulence map, and this is going to kind of give you a graphical representation of what turbulence is going to look like in the area. Once again, we have our weather altitude filter that we can adjust here. And the color and the shading is going to indicate the intensity of turbulence. So it's going to operate similarly to a NEXRAD overlay, where green is going to be mild, and as you get more into the oranges and reds, it's going to get more severe. Keep in mind, it's going to be really easy to confuse this with a NEXRAD overlay. So if you don't know which one you have turned on, you may mistake it for precipitation, or vice versa if you have NEXRAD turned on. So just keep that in mind. Always be aware of what overlays you have enabled at each given time. Let's enable the METAR overlay, and as we come to the map, you'll see that there are different color-coded flags that appear on the map. The color of the flag indicates the current weather conditions at that location, so you can view the legend up here from the pilot's guide showing all the different colored flags. And it's just like the PIREPs, where if you want to view more information about that METAR, just click on it. It will show the location, and it will show kind of the translated data. And if you want the raw text data, you can come down here. Now, a lot of these METARs are grouped together since we're zoomed pretty far out, but I do want to show one other feature. If we zoom in, and if there are any TFRs available for that area as well, it will be available underneath the raw text METAR data. So here in one screen, you can get the current weather observation as well as the forecast for that area, so it can be very handy. As well as the colored flags available will kind of allow you to paint a picture of what the VFR versus IFR conditions are throughout an entire region. So let's enable the SIGMET layer and move over to the map, and we'll see where it communicates significant meteorological conditions for a regional area. Unfortunately, there's only one on the demo unit, but you'll be able to view SIGMETs for the entire continental United States on your unit in real time. If you want to view more information about the SIGMET, you can just click on it and it will pull up the raw text data. And you can see that this one's indicating some pretty severe winds. So winds are at 47, gusting 54 knots. So this was definitely information that you want to pay attention to if you're looking at flying in or over that area. Strolling over to page 3 of these overlays, we can enable center weather advisories, which are unique to FIS-B. And these are going to communicate en route and terminal weather conditions in 2-hour chunks of window, and they are updated 4 times a day. So this is going to be the same way where you can view when it was issued, and then the period in which it's active for, so the active and the expiry times, and then the raw text report. And so this one's indicating moderate turbulence and severe mountain waves. So this is going to complement SIGMETs pretty well. It's where if there's a center weather advisory for an area that you're looking to fly over or fly into, you should probably definitely check it out because it's going to be worth your time. So the G-AIRMET overlay is another one that can be kind of overwhelming at first glance, so just bear with me. And this is going to indicate potentially hazardous conditions for single engine or VFR operators, and it's going to indicate a variety of different conditions. So if you want to view the different conditions that it covers, we can go over here to the settings, and you can see it indicates freezing level, icing, IFR conditions, low level wind shear, mountain obscurations, surface winds, and turbulence. So each one is indicated by a different colored overlay here. It's kind of the same as the SIGMET, whereas we click on it and we can view the information for that graphical area. So here's mountain obscurations due to precipitation or IFR conditions. And you can view this for anywhere in the United States. So say we come over here to the Great Plains and it indicates a freezing level at 8,000 feet. So this can be really good information to know. And what I would recommend is only enabling the layers that you want to view. So you can come over here to the settings and enable and disable any of the filters that you'd like. So you can enable or disable any of these layers here to make the map just a little more bearable. So you can see now it's kind of some better information to work with. The last overlay that I do want to talk about is not for weather, but for TFRs, which there is a map overlay for this, which I also recommend turning on, but it's just a good way to enable these TFRs to make sure that you don't bust into any airspace that you shouldn't be in. So it's my understanding that the more permanent TFRs, say around power generation buildings and stuff like that, is going to be indicated by these yellow squares. And the temporary TFRs, mostly around sporting events or presidential visits, anything like that, will be indicated by these little yellow circles. If you want to view more information about a TFR, you could click on it and see when it's active for, its altitude restrictions, and then some more details about what it's about. So although this shouldn't be your primary source for figuring out where TFRs are, it's always good to have this supplemental information. I do recommend throughout your flight to either be talking to ATC, getting flight following, or call flight service ahead of time, tell them your route, and just make sure that there's no temporary flight restrictions along your route. Now I know it may be easy to rely solely on the GPS, but it is important to always have a second source of information, just making sure you have the most up-to-date info on TFRs. The last thing we want to do is bust into an airspace and lose our pilot's license. Okay, so this concludes my detailed overview of FIS-B weather and the Garmin GPS Series navigators. As you can tell, there's a lot of really good information packed into these units that can be very helpful in making sure that you have a safe flight. It's my recommendation to you that even though you may not use all of these layers, it's important to at least have a general understanding of each of these layers in case you need to use it someday. If you have a question, leave it in the comments below. I'll get back to you as soon as I can. I thank you for watching this video till the end. If you made it this far, it sure means a lot. You guys fly safe, and we'll see you in the next video. Thanks.